In this tutorial, we'll be thinking about a very simple thing, which is measurement. So sometimes in molecular visualization and simulation, we need to be able to measure the distance away from 2 points in the structure, and we can use PyMol to do that for us. So first, I'm going to interest in what residues is near to my PIP2 ligand. So I'm going to click PIP2, and I'm going to go for action. I can't see action. There we go. Modified around residue within 4 angstrom show as sticks, and the residue should come up. And of course, I would like to color this by element so I can see which element they are. First, I would like to look at the distance between this oxygen and this lysine here. Actually, let's go for this lysine to see whether they are making interactions or not. Sometimes we use 4 angstrom cutoff, 3 angstrom cutoff, depending on which parameters and which ideas you're using. But what we can do is go on wizard, measurement, and what you can do is look at here, you have distance, so you can measure the distance between this nitrogen here and the oxygen here. And here we show it's only about 3.3 angstrom, so they're definitely making contact. What we can also do is measure the bond angle. So if you're interested in this, let's say OCN bond angle, you can change from distance to angle, and you can measure these angle here between 3 points, and you can see that it's pretty flat ring, not ring. It is a pretty flat trigonoplanar structure, which is 122 degrees in this built structure. You can also look at a torsion angle. So, if you're interested in how much this is rotating, so you can go on dihedrals and you can pick 2 points of interest. So let's say 1, 2, 3, 4. What this is telling us, the 4th atom is not being clicked. Let's go on this atom instead then. 1, 2, 3, 4. There we go. And what this tells us is a rotation around this bond, which is at -71.4. So this is one way of measuring torsion angle or rotamer. You can also see here that every time I click on these atoms, these will pop up on a terminal window up here. So you can have a track of which atom you're actually clicking, and you can see what have you actually done. Sometimes it can be quite awkward to measure the distance and stuff. So when we do molecular dynamic simulation, you usually pick index and you pick the index of the other one and you measure the distance over the course of a trajectory, which can give us a much better sampling of the structure rather than a crystal static structure. But for a typical visualization of a structure and looking at how it might work and give us some ideas of how it might relate to function, these little tools in PyMol could provide you a guideline which can help you to get through the basic understanding of the molecular structure. Thank you very much.